Hi, Ian from Pentest Partners here, doing my first video about my Making Dumb Things Smart project. So first up, apologies to Big Clive for stealing his video format, but you know, if you're going to copy something, copy from the best. Right, so what am I doing? Here at PTP we have a history of taking things that shouldn't be connected to the internet, pulling them apart and proving exactly why they shouldn't be connected to the internet. I've decided to flip that on its head a little bit and try and take something which isn't connected to the internet and see if I can actually do it while it still remains secure. And that is in the face of our captive Pikachu we have at the hardware lab, Andrew Tierney and the rest of the hardware crew. So let's see if we can pull it off. Now first of all, I need a dumb device. So this is what I've got. This is just an LED light cube, which you can get from Amazon. You can get them all over eBay. You can get them in a variety of sizes, but I initially got this one to act as a nightlight for my kids. Simple plastic construction. It's got some ports covered on the back, very well covered actually, very well constructed. It looks like it's actually designed to operate outside. I mean, the instructions don't actually tell you to do that, but I know the diagrams of some of the bigger ones, and you can get them, you know, as big as a coffee table, do actually show them being put around outside as decoration. So they've done a good job of waterproofing by the looks of it. It's got power inlet for 5V DC, which you power it with an adapter, and it's got a simple on-off button. It also comes with an infrared remote control, which is going to be key to the project, as we'll see later in the video. So just show you what it does. Press on, it glows. Turn it off. Well, you don't turn it off, you press it again and it cycles through. It'll do flash programs, it'll fade, and you can also control it with the IR remote. So if I turn it off, listen to me, there we go, probably needs a new battery. Right, so the initial plan when I saw this was I thought there would be enough electronics in here that I could tap into it with a device like an ESP32 and literally just plug it into the Wi-Fi and send control signals into whatever was dealing with the infrared remote. That turned out not to be the case. Now this one is actually my son's nightlight, which is why it's still in one piece. Let's show you what happened when I actually looked inside one. So, this is what it looks like inside. It's a circular module with a plastic dome ultrasonically welded onto probably like a 1.5 centimeter threaded lip. It is incredibly well waterproofed, as evidenced from the outside. Someone's actually put some thought into this and decided that they actually want this to be usable outdoors. This sort of scuppered part one of the plan. I was assuming that there would just be bare electronics in here, or there would be some way for me to remove any cover easily to gain access to the electronics and put in everything else that I was going to need for the project. That turned out not to be the case. So, a judicious application of the hacksaw later, and we can remove the dome, and let's have a look at what we've actually got. Let's zoom in. Right, so what do we have? We have a LiPo battery pack. We have Here is the switch, the on-off switch that we were seeing earlier on the outside. Here's the there's the input for the 5 volts DC from the adapter, and on top we have a single board. Now I was hoping there'd be something, well, obviously modifying one of these bought from the internet to then make it smart is going to require removing the dome, and I didn't particularly want to do that. I wanted to be able to get something, undo a couple of screws, solder on a couple of things and be done. So that's not the case. So at this point the plan changed to, how can I take one of these and interface with it with an internet connected device without actually having to destroy it. So let's have a look at what we've actually got. So we have the 5 volt in from the external adapter going through a Zener diode, which from what I can tell is there to protect the adapter, the power adapter, in case anything happened and the battery decided to start discharging through there. We have an AP 5056 LiPo battery charger IC. What this does, it's got quite a few functions. This certainly doesn't use all of them. It takes the 5 volt in from the adapter, and then it charges the 3.8 volt LiPo battery we've got here. It uses resistors to set the charging current and all that sort of thing. You can see those here. It has the ability to do temperature sensing on the battery. That's not configured here, they don't use that. But either way, it takes the voltage in from the 5 volt DC, charges the LiPo battery. The LiPo battery then provides power to the rest of the circuit. So it is battery driven. You can use it plugged in while it's charging, so it won't disconnect the battery from the rest of the circuit while it's charging, so you can just leave it plugged in and it will work fine. I did find during testing that you can actually run this with the battery disconnected and take the power directly from the LiPo charger IC. However, it doesn't seem to like that very much, and if you put it into a configuration where the LEDs are drawing enough power, too much power, the whole thing will just shut down. So you can do it. I don't recommend it. Leave the battery connected. So next up we have this infrared receiver module. This is what takes the input from the IR controller here. As you can see, my camera doesn't actually have an IR filter on it, so you can actually see the light being sent and the pulses. This takes the information from the IR controller and sends it to this IC. Now, this IC caused me a lot of headaches. I should probably preface this with, I don't know what I'm doing. The last time I did electronics was in secondary school, which was a very long time ago. So I have a basic understanding of passive components. ICs are a little bit more work. So this one, I naively assumed that it was some kind of very small microcontroller that had a tiny little bit of memory in it, had been flashed with a program which would decode the IR from this IR receiver and then decide how to configure the LEDs for whatever color or pattern that you wanted to display. And I thought maybe I can get some code in here and I could maybe interface with this directly at some point. Turns out that's not the case. This is a very, very, very standard LED driver. They're in just about any multi-LED device that comes out of China, and I can't find a data sheet for them. I'm sure there's data sheets out there, but I couldn't find one. So going around it with a multimeter to figure out what was connected to what, it takes 3 volts in. It's got a ground connector. It's got a data input from the LED receiver. It's got an input for the momentary switch, which we saw earlier, and it has 4 outputs. And each one of these outputs drives a transistor, which and it'll drive the transistor because this can't put out by itself enough current to drive all of these LEDs. It's like an Arduino or something like that. It'll put out probably about 20 milliamps max before bad things start happening inside and the magic smoke gets released. So what it does, it switches these 4 transistors here from the 3.8 volt supply to drive 4 channels on each of these 6 LEDs. So these LEDs are a package, an RGBW LED package. They take 4 inputs, 1 for each channel, 1 for white, 1 for red, 1 for blue, 1 for green. And in this case, they are configured in series. Now this confused me a little bit. Thank you very much, Cool King, who designed this. These LEDs are labelled D1 through D6. The IC outputs into D1, which then goes around in a circuit through D6, D5, D4, D3, D2, and then to the ground plane. And that's it. All of the intelligence in this device is done in this IC, and it is completely standard and it's just totally unprogrammable. As far as finding a dumb device to start with, this is about as dumb as it gets. Okay, so there's the device. In Big Clive style, I have drawn out the circuit diagram just to make it a bit clearer. So we take the 5 volts in here through the Zener diode into the LiPo charger circuit. This then has an output to manage the battery here. Here's the LiPo battery. Over here we have the IR LED. Now, one thing I didn't mention when I was doing the tour of the board, it's not just an infrared LED. You'll notice it's actually got 3 pins on it rather than 2, which is what you'd expect for a normal diode. That's because these IR receiver modules have got a little built-in amp to amplify the signal they receive from the remote control. So it actually takes 3.3 volts into 3.8 volts into its inbuilt amp, and then sends the output of the infrared receiver into the LED driver. Again, the LED driver has 3.8 volts in. It has the input from the IR receiver. It has a ground connection, and it has this momentary switch, which you can use, as I showed you earlier, to switch the device on or send it through a set of pre-programmed modes. The output of the LED driver goes through these 4 transistors, each of which switching the 3.8 volt supply from the battery through the 6 packaged RGB LED modules. Right, so that's it for the actual device. What's up next is how on earth do I talk to this? So, with that out of the way, we bring in our trusty Arduino. So, as I said earlier, this isn't my area of expertise. My work for PTP is as a pen tester. I'm not on the hardware team. I do infrastructure testing. I do web application testing. I do not do hardware testing. So I'm starting this from absolute first principles. So what I want to do is figure out a way to, well, first of all, if I'm going to talk to it, I need to understand the language that it's expected to be spoken in. And all I've really got to go off is this infrared remote control. These are commodity. You can buy them in packs of 100 from AliExpress. But I couldn't find a data sheet out there for them. And I thought it's probably best if I could figure out directly from this device what codes it's sending, so I'm then in a position to build something else that can actually send those for me. Okay, so we're at the point where we want to know what codes this is sending, so we can then play them back when we want to, when we've got our final circuit built. So what I've done is put together a simple circuit here using a not quite Arduino Uno board wired up to an IR receiver. Now this is the same type of IR receiver that you'll find actually on the device we were looking at earlier. It's got a little amp in it, and it will take the infrared signal and then send it out, in this case down to pin 7 on the Arduino, which will then translate that using the IR library that you can download from the Arduino library store, and tell us what it's actually sending. It's probably one of the most simple circuits you can get, so let's have a look at it. So if you look on screen now, you'll see we have the code. This is the code that I sent to the Arduino. Really simple. Sets the receive pin, sets the constant for receive pin, turns it on, and then calls the decode results. And it just goes into a loop where it receives, and when it receives something, it will then send out the data to the serial line. So we've got the serial line here showing us what's going out. So if I press like the off button, we'll see the code F74OBF come up. This is it's a 6-byte code. I know from playing around now this uses the NEC standard. There are a few different infrared standards out there. This uses the NEC one. One thing you can do to tell that, if you've not got any more information, if you hold a button down, it will send blocks of FFFFFF to say that the last button was repeated. So it doesn't have to keep sending the code again and again. So there we are, and each one gives a unique code. Although I think the battery's running out on this one, because the correct codes are the ones beginning F7. The other ones, it's either picking up interference or somewhere, which I don't think is correct. Potentially from LED lighting actually. Or the battery's going low in this and the signal's weak. But what I did was go through each of the buttons and write down what I got, and this is what we got. So brightness up and down, off on, and then each of the color buttons, and here are the feature buttons as well: flash, strobe, fade, and smooth. So now that we've got the data that this sends, we can build another circuit to send that data and see if we can control the device. Okay, so now we know the codes that the remote's sending. We can put something together to send that code, or those codes, ourselves. So what I've got here is the same Arduino, except this time instead of an IR receiver, I've hooked up an IR transmitter. The main difference between these two being that the transmitter doesn't actually have any amplification. It just takes 2 pins, one for the data and then a connection to ground. Interestingly enough, the module that I bought, in fact I'll pull it out and show you, the module that I bought actually has 3 pins on it, and one of them is labelled up as VCC. So it looks like it will actually amplify the input. It doesn't. I traced it out with a multimeter. That VCC pin isn't connected to anything on the board. And there aren't any amplification components on there anyway. I have no idea why they did that. It was very confusing. So there we are. So I'll plug it back into the board. So if you look on screen now, this is the code that's currently running on the Arduino. This is part of the IR remote library using the IR send function. And what I've got it doing is doing a loop, a 3 iteration loop. It'll come on. So it'll start by sending the power on code. It'll wait for 100 milliseconds. It'll then send the red 1 code, as in the top red R button on the remote. It'll wait 100 milliseconds. It'll send green. It'll wait. It'll send blue. It'll wait. It'll send white. It'll wait, and then it will turn it off. It'll then wait for 5 seconds and then do it all again. So this is now confirming that we've correctly identified the codes that the remote's sending, and we can build a circuit to send those codes to the device, and the device will respond. Where we go from here is actually the meat of the project, and it's where most of the work is going to have to be done on this. So what I'm going to be doing is, or at least the plan is, to take this very simple circuit. Now the reason, it's not just because I want to get them on the same screen, the reason that they're so close. Currently, the power output from the Arduino will put out 20 milliamps max, which isn't enough to actually put out a very strong infrared signal. And the remote control, you can actually see the flashing on it. You can't see any flashing on that because the signal's so weak, so that's why they're having to be so close. So the final circuit, which I'm going to have to put together, which I don't have the components for at the moment, will have a transistor. So it'll take the signal from the Arduino, the actual IR signal, and then it'll use that to switch a transistor, so I can put 5 volts through it at however many amps I can manage, which will give a much bigger signal on the IR transmitter and give us a much greater range. You don't want to have whatever device we end up building sat right next to your device, and it would be nice to have something along the lines of like the TV Be Gone, which does the same thing with transistors, which has a very large range. So what the plan is to get, if I can get the packet open. So going forward, the plan will be to use one of these. This is a ESP32 Espressif development board. This contains the ESP32 chipset. It's a system on a chip that includes protocols like Wi-Fi, Bluetooth, BLE, and I will be using this as the base of the device, putting this circuit on, writing firmware for it, and incorporating it into a cloud managed service, so you can have multiple of these devices connected to your voice assistant and get them to send out IR commands to your IR devices. Now the idea is to do this in a secure manner. Anyone can bang a basic ESP Wi-Fi device onto the back of a circuit and connect it to the Wi-Fi, and it'll be good to go. Unfortunately, they're generally quite bad when it comes to security. So the plan is to build something that you can enroll to your user account securely. When you say, I'm not going to do this as a product you can buy, but as a demonstration of how to put together a product that you might want to sell. So secure enrollment, secure firmware updates, secure management of devices, and a secure API that keeps users' data separated from each other. That's something I'm definitely going to ask our guy Vangelis to have a look at, because he's an absolute monster when it comes to APIs. So yeah, that's the plan. Take this IR sender circuit, beef it up a bit, bang it onto an ESP32, and make it into a cloud managed device. So that's going to take quite a bit of work. I'll do some update videos as that progresses, but hopefully by the end of it we'll have a step-by-step guide on how to do this properly. And I'll see you on the other side.